Welcome to solverfy.
Let's first define the estimators. The first estimator is e to the u squared times 1 plus e to the 1 minus 2u over 2, where u is uniformly distributed over 0 to 1. The second estimator is where u1 and u2 are independently and uniformly distributed over 0 to 1. And now we want to calculate the expected values. So the expected value of the first estimator would be the expected value of e to the u squared times 1 plus e to the 1 minus 2u over 2. And since u is uniformly distributed over 0 to 1, then this would be equal to 1/2 just rewriting some things and simplifying. Since e to the x minus 1 squared is the same as e to the x squared minus 2x plus 1 by expanding the binomial, and that's equal to e times e to the x squared minus 2x, and if we integrate this from 0 to 1, then we get 1/2 times the integral from 0 to 1 of e to the x squared dx plus the integral from 0 to 1 of e to the x minus 1 squared dx. And this is ultimately going to be equal to the integral from 0 to 1 of e to the x squared dx, and that'll be equal to theta. The expected value of our second estimator that would be equal to the integral from 0 to 1 of e to the x squared dx as well. Both estimators are unbiased, and to compare the estimators we need to calculate their variances. So the variance of the first estimator is equal to the expected value of the first estimator minus the expected value of the first estimator squared. And for the second estimator, and given the structure, it would be clear that the first estimator will have lower variance because it involves averaging the term, the exponent of u squared directly, and combining it with an additional deterministic part, which is e to the 1 minus 2u, reducing the overall variance compared to averaging two independently generated random variables, which both include the exp of ui squared term. So by calculating the variance rigorously, we could show that the variance for the first estimator is less than the variance of the second estimator, indicating that generating a single random number u and using the estimator e to the u squared times 1 plus e to the 1 minus 2u over 2 is better.